It's Friday evening. Just doing a bit of op-amp research. Alright, look. It's time to make a video. Let's go do this. It's Kitty. Time to make a video. Oh, yeah. Okay, guys, we're turning the geek factor up to 11 this time. This is an op-amp circuit with an audio amplifier attached. I think that unless you've done audio circuits, you're not a proper electronics geek. So this thing up here at the top is just a bunch of batteries in a magazine cover rolled up and taped together. And the reason I went to all the effort of making this, it's got this springy stuff in between the batteries, by the way. This wire does nothing. That's just a spring. Please excuse the shit. Right, the reason that I built this and built little copper springs between the batteries and taped it all together and soldered wires onto the end of the batteries is because I needed a positive, negative, and zero voltage. So we got these two wires coming from either end here, and one wire where it's joined together there. If I measure from here with the negative probe to this one with the positive probe, you can see positive around about 5 volts. And to this one, we can see negative 5 volts. And that's pretty important for the op-amp. You can do it without the positive, negative, zero voltage. But the only thing is that the output signal has then a DC offset, which really, it doesn't matter, but I made the batteries because it was fun, alright? Hey guys, let's get this thing on the road! So first, I'll ground out the probe in the ground rail. Okay, the probe, and then we'll take the positive into the positive and the lower rail into the lower. Okay, it's going! So if I take the probe and put it over here, we get a nice square wave. And if I take the probe and I put it over here, there's another square wave. Where's it? That one. There we go. A nice triangular wave. And by adjusting the potentiometer, we get variable frequency. And we can see that that's at about 500 hertz, which is it's very sensitive to temperature. If you just wobble the circuitry, you can get a lot of variation. Anyway, 500 hertz is around about the frequency of a male voice. Not mine though, it's my voice much lower. So let's test it out. I shall power up the audio circuitry over here. Let me just bring you a bit closer to this side again. So we've got 5.7 volts, that should do the trick. We've got this little speaker over here, which I pulled out of a old telephone. And we'll just activate the... Oh, that's the input. We'll just put it there for a second. And ground to ground. Okay, we have the amplifier turned on. Okay, and we'll put this, first of all, where the square wave is. Let's try that. Awesome. So there we go. Now we'll put it where the triangular wave is. There we go. So let's put the probe on that at the same time. Oh, guys, that's so cool, man. It's so cool. It's so cool. Anyway, that gets old real fast. Now to build something cool with it. I don't have any ideas. So basically, I just got an op amp in this configuration. This is a bistable oscillator. It produces a square wave. That's what this does. And this potentiometer was what I was controlling the frequency with. I then use an integrator, which looks like this. This part is an integrator. And that integrates the square wave and turns it into a triangular wave. And that is what we are hearing. Doesn't it sound glorious? Hey guys, thanks for watching and see you next time.